The video you are about to watch is from an old woodworking magazine that I published during the years of 2003 to approximately 2006. This was a very unique magazine. It was purely video content and it was distributed on DVDs. The magazine ran for approximately 3.5 years, and then due to financial concerns, we simply had to terminate the magazine. We moved on to other things over the last roughly 15 years. However, there has been a request to resurrect this content, so I've gone through the trouble to get the equipment, the products, everything I needed in order to bring this content back to life to share with everyone. Here on this YouTube channel, we'll be putting up approximately 100 to 120 of the original stories that appeared in that magazine. The magazine was called Woodworking at Home Magazine, and it was truly one of a kind in the world. I really hope you enjoy these videos, and please tell your friends about them.
Router table systems can easily set you back between $400 on up to well over $1,000, not counting the price of the router. Now, router tables are really an offshoot or a hybrid system of a shaper, or a spindle shaper as they're called. Now, spindle shapers have the large arbor to mount large cutters in them, have a large cast iron table, and so forth, and they perform very well. Now, shapers generally run in the RPM range of around 7,000 to 10,000 RPM, and that's suitable for efficient cutting with a cutter diameter of about 3 inches on up to 5.5 inches. You start getting smaller than 3 inches, 10,000 RPM starts to make the cut much less efficient, and you get a poor quality finish, we'll say. Routers, on the other hand, generally start at about 10,000 RPM and go all the way up to 20,000 RPM. So in that case, the cutting efficiency that these are well suited for fits into the cutter diameter range of about 3 inches on down to, say, 1/8 or 1/4 of an inch. So generally, a router table, we can use more efficiently the router bits that are available to us. Router bits are much more economical than shaper cutters as well, plus they're much more readily available. Shapers come in many different sizes. There's the small benchtop variety, generally around 1 horsepower, small units that fit on top of your workbench and so forth. Now, they have a spindle speed range of about 7,000 to 10,000 RPM, like their bigger brothers, but their price range is between about $100 and $250. Now, the next size up is that 1.5 horsepower to 3 horsepower range shaper. Now, those are still very well suited for the home woodworking shop. They still have a 10,000 RPM maximum speed on all the models that we checked. Now, these size units range in price from about $425 on up to around $1,000 and maybe a little bit more depending on features and so forth. Here in our shop, it seems that we're always fighting two economies. The economy of money, which is relative to all of us. We obviously don't want to overspend on a tool or a product or a machine, but we don't want to spend too little and end up with a unit that simply does not perform for us. The other economy is floor space. As we've mentioned in past issues, our shop is only 11 feet deep, 22 feet long, so it fits into that size category of many home woodworking shops. So by adding a spindle shaper into our floor space in here, we lose more floor space. That's at a premium in here. Now, even with just a 2 foot by 2 foot top, that is basically 4 square feet that we lose. And that's a lot in this small space. So there's the economy of space and the economy of money that we have to pay attention to. Now, for most of the work that I've done myself over the years, I've been able to get away with router tables. Now, you can pick from a variety of different size routers, but generally on a router table, you want something with a good RPM range, something that can go from, say, 10,000 to 20,000 RPM to handle the various size cutters that we would be using on it. We want it to have a substantial amount of power. Now, this small trim router probably isn't the best choice, just simply doesn't have enough power to it. There's the fixed base router variety, which this one is. Now this one doesn't allow for ease of adjustability up under a router table. There aren't any devices available that allows you to adjust them while they're still mounted on the fixed base. Now they can be adjusted very accurately, very precisely, and they clamp very securely. But they're a little bit more troublesome, we'll say, to set the bit height. Now you can buy lifts for these types of routers, but we'll talk about that a little later. Now we start getting into the 1.5 horsepower size variable speed plunge routers. Plunge routers are very well suited for router table application because they have the lifting mechanism already built into them. We can mount them up to a rigid plate, and because of their built-in lifting system with the plunge posts, we've got that adjustability, we'll say, in their height or router bit setting. But a 1.5 horsepower router is kind of at the low end when working with large bits. Say you start getting up into panel raising operations where you're working with a 3 or 3.5 inch diameter bit. 1.5 horsepower router is really at the cutting edge there. You're really kind of pushing its capabilities. Now that's not to say it can't be done. I've done it for many years. In fact, 3 of my previous router tables had 1.5 horsepower routers in them. You just take lighter cuts and it slows down efficiency a little bit, but you can still get excellent results. For our newest router table, we're going with the large 3 horsepower Porter Cable plunge router. This is a big behemoth of a router. It's heavy duty, years of proven service, and of course, being a plunge router, it does set itself up very nicely for router table applications. As I mentioned a moment ago, fixed base routers are a little bit more difficult to adjust for router bit height, especially when making fine adjustments. And in most cases, you actually have to take the router out of the table and then make your adjustment and putting it back in. Now that's somewhat true with most of the plunge routers as well. However, some of the manufacturers, such as Porter Cable, are coming up with accessories that you can buy for the router. And this allows you to use their provided handle. Find my hole here. You can slide that in, and then that allows you to adjust the height of the router bit from above the work table. And in their accessory kits, they also have these offset handles that allow you to reach in and change your router bits without removing the router from the table. This particular accessory is not available for our larger router that we plan to use, but we'll address that problem in a moment. Now, as I mentioned, a plunge router is a good choice for in the router table because of its plunging mechanism, the plunge posts and the base. However, there's been a number of manufacturers in recent years that have come out with router lifts. And more often than not, the way they work is you take your router motor out of its fixed base, and then they provide a large housing that clamps onto the router motor and provides a plunging base, so to speak, that you would mount in your router table. And they have a number of different features for very precise control of elevation. Now those will set you back about $190 to $290. Now you can certainly go out and purchase one of those aluminum or stamped steel router tables. And they come in a variety of shapes, styles, and colors and so forth. And of course they work on top of your workbench. You'd bolt them down to your workbench while you're doing your routing operations. But then you have the storage problem. Again, another economy in a shop. You have to have money, space, and storage space. So a router table in here that's separate from another machine creates a problem. Now those router tables that are of the aluminum castings or the stamped steel units range in price from about $40 on up to several $100 depending on quality and features. Now there are composite router table tops that are somewhat prefabricated that you can purchase and adapt to another machine or to your workbench or even as a standalone unit. And those can be picked up from about $100 on up to a couple of $100. For our choice, for our router table, the right extension wing of our table saw is really the perfect place. It fits our needs very well and doesn't take up any additional floor space. Best of all, it's already paid for. Now to install our router in the right extension wing of our table saw, we're going to need a router plate. Now there's a couple of options available to you. There's the plastic variety, and those are around $40. Then the aluminum style, they can range in price from about $70 to a couple of $100 depending on how much machining they do for you. This particular unit cost us about $100, and it was pre-drilled to match up our router, and it's sized accordingly for this router, so that works out very well. Now the thing I like about the aluminum plates, they will stay flat longer. There's less chance for sag, especially when mounting a very heavy router in them. Plus, being aluminum, you know that it's precision machined, or at least you hope it is, precision machined so that the reduction inserts that go inside this opening will fit in there and stay in there nice and flat. And that was one problem that we noticed on the plastic router table insert that we used before. So now our next step is to cut the opening and get this router plate installed. To install the router plate, we need to, of course, cut an opening for the router to pass through, and then we need to leave a rabbet along this edge so that the router plate sits flush with the top of the table. Now to make that cutout, I'm going to start out by first milling that rabbet area. And I've made up a jig here, and it started out with 3/4 inch birch plywood, and I just ripped some 3.5 inch wide strips, cut them off to the appropriate length after measuring my offset for the router base. Then using the Kreg pocket hole jig, I drilled the pocket hole screws, and we can tighten them up. Using one of my drafting templates, I could lay that over the top of my router plate. And it tells me that it's a 1 inch diameter hole, so it means it's a 1/2 inch radius. Now to cut the opening in my table, what I'm going to be using is a WHITESIDE, part number 1094, 1 inch diameter router bit. And that allows me to get that radius in the corners to match up perfectly. Now I can't use a collar with this large of a router bit, so I had to make my template much larger so that I'm using the edge of the router base as my collar, so to speak, to follow the template while we make this machining operation. And it just takes a couple of minutes to figure out your offset distance from the router bit to the edge of the router base. Now before I start cutting the opening, I want to make sure that I've got it positioned on the table where I can work with it comfortably, and because this is an extension wing on my table saw, there's ribbing that runs underneath, so I want to make sure I don't put it right over the top of one of those ribs. So I found my place where I want it. Now I'll use my saw fence to help position my template, and then that will keep the opening nice and square so it looks appropriate. And I've got a stop here on my fence so that I can take the template off, put it back on in case I need to recut something. Now what I'll do is I'll apply some double-face tape to the back of my template, put it back in place, and we can start routing. Now with our rabbet machine, we need to cut the opening for the router to pass through. Now I could just take my jigsaw and cut along this line, and that would actually give me enough clearance, but just barely, because the edge of my router and the edge of the plate is about 1 inch, so I don't want to be that tight. So I'm just going to simply take a number 10 washer, take my pencil, and trace around that inside edge. And that will actually give me about a 3/16 offset. Now that'll be my cut line. After drilling a couple starter holes in the corners to make things a little easier, just take my jigsaw and cut the opening out. After taking a few minutes to knock off the sharp edges with some sandpaper, we're ready for a trial fit. And it fits in our spot real nice. Now if my router plate was higher than the table, I'd need to machine that rabbet a little bit deeper. Now if I goofed up and machined my rabbet too deep, I could just put a couple pieces of tape underneath this edge, and that would hold the router plate up flush with the table surface. Now at this point I want a nice luxury feature. I want the ability to adjust the router bit height from above the table. On our old system, I was always cranking it from underneath. And frankly, the cranking mechanism was very poorly designed. It was just an add-on device that didn't work out real well. Well, we've got a new system that we would like to show you. We'll take you over by the workbench and show you that. The device that we want to use this time is a router razor made by Router Technologies. And it's a device that we will have to make some slight modifications to our router, but they don't really look that complicated. In fact, a couple of the modifications look like they'll even add safety. So what we need to do is remove our plate and get all these pieces put in there. To start assembly, I've gone through and carefully laid out all of the pieces that we need to work with. That just makes the job go a little more smoothly. The first step of installation is to disable the automatic locking feature for the plunge mechanism. So we remove the hardware for the original, place the new spring in there, and tighten that back up. And we'll reinstall the handle. Next, we need to remove the height rod. With that removed, now we can release our lock and lift the router off the base. And with that comes the springs. Using the provided template, we need to drill a hole in the top of one of the plastic handles. Now we can slide one of the bushings on and the main shaft up through that hole that we just drilled. Then we put on a washer and a nut. Now using a socket and a mallet, I'm going to drive out one of the posts. And that post is only press fit into the base. What we're going to do is pin it in there so that the two can't separate. Now we need to drill the holes in the base for the roll pins. Now those roll pins are actually kind of a safety feature. Because the router is inverted and hanging upside down in your router table, those pins prevent the posts from pulling out of the base. Now we can install the component they call a main shaft, along with its retaining clip. Now with all the internal components assembled, we can put the plunge router springs back in and carefully line everything up. And this might be a little bit of a tricky operation, but just take your time and work it down. And now we can go about installing the rest of the hardware. And the last step on our router raiser installation is to provide access for the adjusting screw. We have to drill a 1/2 inch clearance hole in our router plate, and they provide a nice template to help you with alignment. Then you drive in a small aluminum bushing. The next feature I want to add to the router table is a safety switch. It can be considered a luxury item because the router has its own on-off switch, but I like the convenience of having this type of switch with a large off button mounted right up front where I can get at it very easily. Now, as with all switches, you will have to custom fabricate a mounting bracket for it. A short length of aluminum angle and a small piece of plywood should work fine for a bracket to mount up this switch. And using one of the existing bolt holes on the bottom of the table saw that holds the fence rail in place, we can mount up our switch. This is the fence system that we've come up with here in our shop. Now there are some options available to you to purchase ready-made fences. Some of the more basic ones that are either constructed out of composite materials, MDF, wrapped with high-pressure laminate and so forth, or even your more basic style metal fences that are made out of angle aluminum. Those can set you back about $40 to $150, somewhere in that range. Some of the more exotic fences that are much more well-engineered and incorporate many other features, such as miter gauges that attach to the fence and so forth. They incorporate dust collection and so on. Those can set you back a couple of $100. The type of fences that have become very popular in recent years, and I refer to them as indexing fences. Manufacturers such as Incra and Jointech have indexing fences for their router tables. Now those can set you back about $270 all the way up to $480. So it can get very expensive to outfit your router table with a fence. Now before we go into the details of what we did with this fence, let's take a look at what our old fence was like and what we want to change on it. Now this happens to be our old fence model. We're going to be making some modifications to it. It served us well over the years, but there are a number of problems. For the fence faces, we used UHMW tape. Over time, it's come loose and it's become a nuisance. so we don't want to use that. To attach it to our table saw fence so that it can ride along with that, we use these large toggle clamps. That's worked out fairly well, but as you can see, it's rather bulky. I think we can streamline that process as well. I am going to be mounting it against my table saw's fence because I like the indexing that it provides for me. If I want to move the fence in a 64th, I've got my calibrated scale already on the table saw's fence. So that works out very well for this application. I got started by first cross-cutting the plywood into its overall length. Then I ripped the components to their proper width. The next step was to cut these diagonal corners on our back panel for the fence, and that's just so there isn't a sharp edge there. Now this back panel for the fence assembly, we want it to overhang the front and back edges by 2 inches, because what we're going to do is put some clips on here that will hook around the fence and clamp on this outer board. Now, as you saw on our old fence system, the main body of the fence was a square tube. Now in this case, I want it to be 6 inches high, a little bit higher than my old one. The width inside this tunnel area, I want to be a little over 3 inches because I'm going to be putting a 3-inch dust collection hose at this end. So I've ripped a couple strips to 3 inches wide, one for the bottom. Here's the mounting surface for our adjustable fence pieces, and then the top piece. Now the overall length of the fence for the portion that we are using as a fence, keep in mind this backboard is helping us fasten it to our saw fence, I want it to be about as wide as my router table's surface. In this case, it's 27.5 inches. So I'll cut off my other pieces to 27.5 inches long. Now my next step is to cut away a clearance area in the bottom plate and partway through the front plate. And those will provide clearance so that we can slide the fence over the top of a router bit and bury it inside the fence. And I'll show you on our old system how we went about that. As you can see, we've got our opening cut out here and in this area. Now on the new one, I'm going to cut a 1 3/4 inch radius back in this area. And I want that to start about 3/4 of an inch back. And that way I can bury most of a 3-inch diameter cutter inside the fence. On the front side of the fence, I'll come up about 3 inches and cut out a square opening in that place. Because I want to incorporate dust collection into my router fence, I need to provide access for the dust collection hose. So I need a 3-inch hole on this end, and on the opposite end cap at the other end, I need to drill some 1/2-inch holes to balance the airflow. On the original fence, we used a single screw in a slot to allow for adjustment of our fence opening. Now it did work out, but I don't like that system. I'd prefer to have 2 screws on there so that when the fence sections are loose, they don't fall out of place. So what we're going to do on our new fence is on the box area, we're going to mount some of this aluminum T-track. That's going to require us to machine a dado on the front face of the fence. To machine that dado, I'm using a router bit mounted in our new router table, and we'll cut that dado now. Using a hacksaw, go ahead and cut off the T-track to fit into the areas on either side of the opening. Now what may end up happening, you may end up not having some screw holes to fasten it to our board. Using a countersink in the drill press, we can easily drill out a new hole and add the countersink. On the sliding portion of the fence, we want to have something that's straight, flat, and will hopefully remain that way. We also want it to be a nice slippery, smooth surface. So we're going to use MDF for a core material because of its stability, and then we're going to wrap it with high-pressure laminate. I'm not actually trying to make my fence look like granite, but this is the only color that I had a choice of over at the home center when we picked up the high-pressure laminate. Now I'm going to cut this using the same technique that we used to cut the veneer in our other story. With all the pieces now cut to size, we can go ahead and start applying a contact adhesive to glue them down. Now I'm using a water-based product here because I want to experiment with it. And I find that shop jigs and fixtures are always a great place to experiment with things because you're going to, of course, be putting them through quite a rigorous use over time, and you can see how things perform. So if I end up seeing this fail for some reason, it's not the end of the world because I can just simply remake the jig or fixture as opposed to a piece of fine furniture. Now I should point out that when you cut your high pressure laminate, cut it oversize. You'll trim it up to actual size after you get it installed. Now this type of adhesive requires a little bit of pressure to set it, so I'm just going to put it in my bench vise and squish it for a moment. With a flush trim bit mounted in the router table, we can trim up the high pressure laminate to be even with the MDF. Where the end cap butts up with our front piece on the fence, we need to make a cutout where our T-track is going. So we'll just mark that and nibble it away at the table saw. Our router fence is going to attach to our table saw's fence in this area right here with a small clamp. Now to tighten that clamp, I'm going to install a 1/4 threaded insert into my back fence rail. And I'll put that in this location. Then we'll just fabricate a very simple little clamp that'll hold everything in place. I also like to put a nice big chamfer on the entrance hole for these threaded inserts. It makes them start much easier. For threaded inserts, I prefer the all steel type that have the Allen drive built into them. Using one of these T-handles, they're very easy to install. For our clamp, we're going to start out with a piece of hardwood. In this case, I've got cherry. It's 3/8 of an inch thick, about 2.5 inches long, and 1 1/4 wide. And that will serve as this component. Now on my fence, the banding that wraps around the laminated faceboards overhangs on this inside edge. So to get around that, I'm just going to take a thin piece of masonite or hardboard and attach that on one end. And that will get us up over that little lip. Then near the back end, once I have everything in place, I'll hold these pieces together, and then I can measure how high I need this back support for the clamp. Cut that to length, and then it's just a matter of glue and a few brads to hold everything together. Now we just need to match up the hole locations and drill our 1/4 inch clearance hole for our clamping screw. Now with the back rail attached to my saw's fence, I can center up my bottom plate right over the center of the router bit, taking my time to get that centered up real close. Then I'll mark its location relative to front and back. For assembly, I'll just be using glue and brads. If you want, of course, you can use screws, but I don't really think they'll be necessary for this application. Now I'll take the front plate and attach that to the top. Now we can go ahead and install our adjustable fence pieces. And I'm carefully measuring how deep I want to set my counter bore. We're going to be fastening this in place with 3/4 inch long, 1/4 button head machine screws. We're also going to be using a washer and then one of these little T-nuts that I got from the manufacturer of the T-track. And that would slide in as so. So what we need to do is drill a counter bore 3/4 inch in diameter to accommodate the washer, and then a through hole slightly larger than the 1/4 inch diameter machine screw. The holes that we need to drill will be 3 inches in from each end and 2 inches up from the bottom edge. With the backer board underneath my part, I can go ahead and drill completely through with the 9/32 drill bit. Now we can install the T-track. With the hardware installed, we can slide the fence pieces in place and snug them up with an Allen wrench. Now what we want to do is plow a dado through the center of our accessory mount. As this is such a deep cut, you should take it in several passes, no more than 1/8 inch per cut. I then placed the aluminum T-track inside our accessory mounting block, and then I drilled through the areas where the screws are. And what we're going to use is the screw that's going to mount the T-track, also is going to mount the accessory block onto our fence system. And now we can attach our router fence and it's ready to use. Well, here's the completed router table system. And it's not short on features or performance. The large 3 horsepower plunge router provides us with plenty of power and RPM range to handle from the smallest to the largest of bits. The router raiser gives me the elevation control that I desired from above the table. The aluminum router table insert is shown to be very solid, very rigid, and it of course is staying very flat even with this big router in it. The front mount switch, great luxury item, and provides easy on-off control right up front where I want it. And our shop-made fence provides us with enough features to make it very useful and beneficial here on our router table. Now let's quickly review the costs of what it took for this particular router table setup. Now the one budget I was most concerned about with is shop floor space. I have none to spare, and this router table didn't cost me 1 square inch of shop floor space. So to me that was a big advantage. Now the router was $320. The table insert is about $70, and the fence cost us about $45. Truthfully, we had all the components here in the shop, but if you had to purchase the components, you'd have to spend a little bit on plywood, some high pressure laminate, and aluminum T-track, and a few nuts and bolts. But that set us back, we figure, about $45. So the total cost of this setup was $435. Now by adding in a couple of luxury items, such as the router raiser, which gives us that elevation control, that set us back another $90. The front mounted switch was $22, so the grand total of this particular router table was $547. Now it starts getting us up into that range of a shaper in price, a mid-priced 1.5 horsepower shaper, but we can get a lot more function out of this, and it didn't cost me any floor space. So as you can see, this particular router table setup was real easy on the floor space budget because it didn't cost us anything there, and it wasn't too bad on the pocketbook either. For a grand total of $547 with this much functionality, it's a pretty good bargain. I'm Chris DeHut for Woodworking at Home magazine. Thanks for watching.
I sincerely hope you enjoyed watching this video. If you truly enjoyed it, please help us share this information with the rest of the communities. Please hit the subscribe button, give us a big thumbs up, and be sure to tell your friends about this channel. Thanks again for watching.